Hi there. All right, we're starting chapter 3, which is on polynomial functions. And polynomial functions are just going to be higher degree functions. So you're going to have quadratics and cubics and quartics and quintics and even higher than that. And today we're just going to start with the quadratics. Some of this is just going to kind of be a recap. You would have done an entire chapter of this in Algebra 2. We're going to condense it to a day. So let's get started. Let's talk a little bit about notation and some terminology here. So this is kind of like what a textbook would show a polynomial function looks like. Your A, B, C, D, these are just coefficients. And then you're taking your x to some power. And then what happens is that power reduces by one and it reduces by another one and keeps going down from there. So notice that it's just kind of a nice, pretty function, I guess. There's no fractions or square roots or weird things happening. It's just a variable to a power. If the n, which is right here, is a 2, that would imply it's a degree 2. So it would go 2, 1, 0, and this stuff wouldn't be there. And that's called a quadratic, if your highest degree is a 2. If your highest degree is a 3, cubic, a 4, and this is a typo in here. We need to fix this. Maybe it's already fixed in yours. That is not a polynomial. It is a quartic. All right, and then it can keep going from there. There are a couple different ways that we can write the equation of a quadratic, and it sort of depends on what you're doing, on which is the preferred method. This form, the standard form, is great for graphing. We've already done some of that graphing, where this just shows really obviously the shifting and the transformations that happen. Another form is general form, and it looks like this. And it is nice, like if you were going to factor, that's great for factoring and doing things in a more algebraic way, like doing systems of equations or something like that. This might be a better form. So let's kind of look at both of these. If you're starting off in general form and you want to get it to standard form, the way to do that is to go through the completing the square process. We did completing the square when we were solving quadratics. Not the most efficient way to solve a quadratic, but it has other purposes, and this is one of them. So that's why we kind of do that completing the square. All right, so the first thing, if you'll remember, now this is actually a little bit different because when we have completed the square previously, it always equaled 0 or equaled a number, and that was usually over on the other side, if you'll remember. So keeping that in mind, it's going to play out a little bit differently because I'm going to have a y value here or an f of x, and I need to keep that there because ultimately I want it to end up with a y equals blah, 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 blah down here. All right, some of these processes should sound familiar. The very first thing I want to do is I want to move all the constants, all the number stuff to the other side. So that's going to look like f of x minus 16 equals, okay, and then I'm going to kind of cut to the chase here. And then what's left would be this right here. And remember that you always need this to have a coefficient of 1. So of these two terms that are still left here, I'm going to factor this 2 out. Now, I'm not pulling out the GCF, because if I was doing that, I'd pull an x also. All I'm doing is pulling out this coefficient, and it will always be that coefficient. Sometimes it comes out nice, sometimes not. I'm giving you a nice one. So when we pull that out, it looks like this. And now you're ready to complete the square, which means add in a number here that is going to make this be a perfect square trinomial. To do that, we take half of this number and square it. So half of 6 or negative 6 is a negative 3, but you always square it so it always ends up positive. So that's going to turn into a plus 9. But when we put that plus 9 there, we really put a plus 18 because of that 2 is getting multiplied by that 9. And so we need to do the same thing on the other side. So I'm going to do a plus 18 on this side. All right, so then our next step will be to have an f of x, or sometimes we write y, plus 2 equals 2. And the whole point of completing the square was to get this to be a binomial squared. And that will break down to an x minus 3. Now, thinking about where we're headed here, we're not trying to solve for x, we're just changing the format of this equation. So I'm going to bring this 2, it's ready to come back over to this side. So I kind of move it to get it out of the way, and now I'm going to take it back. And it looks like this, and that's our standard form that we like, where you can tell the graphing parts of this real nicely. All right, so we went to the work of putting that into a nice graphing form, so let's go ahead and graph it. Now, recall for a quadratic that the vertex on the parent graph is at 0, 0. And so what we're going to do is we're going to do some shifting of that vertex. And right here, if you'll recall, that tells you what your shifting is. This right here indicates that you're going to end up going right 3. This indicates that you're going down 2. If you take your vertex and you go right 3, down 2, okay, that's your new vertex. So let's write that. It would be 3, negative 2. Now, if you can imagine a parabola that has a vertex at 3, negative 2, and then it's just going to open up like this, it's going to create this nice line of symmetry right down the middle of that parabola. So it's a vertical line. So recall that vertical lines are written with an X equals, and then wherever that would cross the x-axis. Well, it's going to go right through the vertex. The vertex is a nice center point for that symmetry. So you can see in your vertex that the x value is 3. That's where your axis of symmetry will always go. So x equals 3 is our axis. Now, if you want to find your x-intercepts, you're looking for where this graph will cross the x-axis. The best way to do that would be to factor. Factoring will help you that. The general form is an easier way, or is in the right form to be able to factor. So let's go back to that. It's 2x squared minus 12x plus 16. Now, if you're looking for the x-intercepts, consider what the y value is everywhere on the x-axis. It is always 0. So what you do is you take your y and you set it equal to 0 and you factor. Now I'm going to start by pulling a 2 out because that's going to make my life way easier on factoring. And then I'm looking for factors of 8 that add up to 6. All right, that's pretty easy. Signs are the same. They're both minuses. All right, then you set everything equal to 0. Remember that if you set the 2 equal to 0, that doesn't really mean anything. That's not a true statement. That's only going to get you a 0 if there's an x with that 2. So in the end, I'm going to end up with a 4 and a 2 for my x-intercepts. So let's go plot those. On the x-axis, it's going to happen right here and right here. And then when you look at where your vertex is, you're at 3, negative 2. That should make sense. Look how that's centered in there nicely. Okay, the other thing that you can kind of pay attention to is the fact that this 2 right here is really the same as this 2 right here. So when it's in this form, that's your vertical stretch. And if you'll recall from our parent graph, it normally would go over 1, up 1, over 2, up 4, over 3, up 9. But because it has that a value of 2, you take all of those times 2, which means you're going to go over 1, up 2. Yep, that's where it landed. And I could finish that. I could do that again. I could go over 2. It's not going to be up 4. It's now going to be up 8. So it's going to go to there. So I can graph this in that form also, except that I had to complete the square to get this vertex figured out. So I knew where to start it. Okay, so here's the deal though. I'm not going to do it, but I'm going to talk through it. If you were to take this general form of a quadratic and complete the square on it, like not with numbers, but with actual just variables sitting there, and you run through all those processes of completing the square to get it down to this nice standard form, you're going to have a bunch of variables sitting there. But if you do that, you are going to end up with what that would look like is this y equals a, and then right here you're going to have an x minus h plus k. And right here, where this h is, would actually end up being kind of a little formula. And what it would look like is negative b divided by 2a. That is what would go right there, which really tells me that that's where to shift horizontally, and that's going to be the x value of your vertex. I bet you with some refreshing your memory, you probably remember that from Algebra 2. The x value of your vertex is always negative b over 2a. Now, when you complete the square over here on this thing, the k value is a mess. There's a lot of stuff going on. So rather than trying to remember what the k value is, we typically will just take whatever value this is and we'll plug it back in for the x and see what the y equals. And so let's go ahead and write that. I'm just going to say plug into function. And hopefully that'll mean something to you. Okay, so let's go back and try it on that previous problem. If you'll recall, on the previous problem, we had an f of x equals 2x squared. I think it was a minus 12x and a plus 16. If you were to do the negative b over 2a, negative b would end up a positive 12 over 2a, so that'd be 4. Okay, so that equals 3. You can peek back. Yes, 3 was the vertex x value. If I wanted to find the y value, I would take 3 and I would plug it in right here. So that'd be 9 times 2. That's an 18. Now plug 3 in here with this x on the 12x, so that'd be a minus 36, and then a plus 16. And when you combine those together, that's going to be a negative 2. And so there's our vertex, just like we got from completing the square. So I'm going to let you off the hook. We're actually not going to complete the square. We're going to instead use this formula here, which ultimately is just coming up with a pattern from completing the square. Trying to be efficient. All right, so let's do this one. The very first thing I'm going to do, it's in general form. I'm not going to complete the square. I'm just going to do my formula. I'm going to do negative b over 2a. So that's going to be a positive 8 over negative 2 times 2 is a negative 4. So that gets me a negative 2. That's the x value of your vertex. Now you're going to plug negative 2 in right here, squared, so that's a 4 times the negative 2. Then you're going to plug a negative 2 in here, which is going to turn that into a plus 16 and then a plus 1. So that's a 17 minus the 8. That's 9. So my vertex is negative 2, 9 right here. Now, at first I was kind of scared about that, except that look at what I've got. I have a negative a value. That's going to tell you that it's going to open downward. And so I am going to have some space on here to graph this. In fact, let's go ahead and graph it, and then we can look at that graph and we'll find our axis of symmetry. I'm going to use this negative 2a value to do this. Remember that the table, now I'm writing the table because we're doing kind of notes, but ideally you don't have to have this table, that you just remember that you're going to take all of these times negative 2. So I'm not going to go over 1, up 1. I'm going to go over 1, down 2. And instead of 2, 4, it's going to be 2, negative 8. And instead of 3, 9, it's going to be 3, negative 18. That would take me to here. All right, let's graph it. Oh, that's not very pretty, sorry. Okie doke. And then my axis of symmetry is going to cut this thing right in half, right down the middle here. So that's another vertical line. And the x value at my vertical line is a negative 2. It always matches this. Axis of symmetry, x equals negative 2. All right, so I would like you to practice one of those all on your own. So I'm going to have you pause the video, Once you're done with it, come back and we'll keep moving. All right, so here's my answer. It looks a little bit messy, so I kind of color coded it. The first thing you do is this right here. You do the negative b over 2a to get 4. You take 4, and step 2 is the red. So you plug 4 in to see what you get. I got negative 3. And then step 3 here is in green. I plotted the points, remembering that this a value will affect the parabola. So it's a little bit wider than normal, and pulling that axis of symmetry. All right, let's keep going. Let's talk a little bit more about the x-intercepts. Now, the x-intercepts, the one I did for you, it factored beautifully and it came out nice. Okay, that's an ideal situation. Doesn't always play out like that. So if it didn't, you'd go to quadratic formula. And if you'll recall, in the quadratic formula, we have something called the discriminant. It is the part that is underneath the radical. And so what that number is greatly affects what your answers will look like. And what those answers are, the x-intercepts are the solutions. And so if b squared minus 4ac came out beautifully like a perfect square, that would be an ideal situation. Because if you had that happening, then it would the square root would go away and you wouldn't have ugly answers. So in a perfect world, you'd have something like this, where it was a perfect square, and then your x-intercepts actually come out as this on these perfect grid lines. And if that's the case, you really could have factored it. You wouldn't have messed with doing the discriminant or the quadratic formula. All right, so let's say that the discriminant is positive, but not a perfect square. If that's the case, then you'd still have this situation that I just had, except that it's going to come out as some decimal. It's going to be kind of ugly. It's not going to hit grid lines nicely for those x-intercepts, which is still totally fine. Okay, now, if your discriminant happens to be negative, that means that when you take the square root, you're going to end up with some imaginary roots. Now, we've already talked through all of this in a previous chapter, but what I want you to notice is what it means on the parabola itself. So if you were to have imaginary solutions or imaginary x-intercepts, what would your parabola look like? Does that mean there isn't a parabola? No, there's a parabola. It just means that it doesn't touch the x-axis anywhere. So your parabola would do something like this, where it just doesn't touch the x-axis, and that's why you don't have any. And I'd like to add one more thing in here. I feel like we should also talk about what if your discriminant ends up being 0? Now, it's the discriminant, so it's not the entire answer. You'd still have like this negative b plus or minus the square root of 0 all over 2a. And what that means is that when you get the square root of 0, that's really just a 0. And so whether you add 0 or subtract 0 doesn't really matter. You're just going to have this negative b over 2a, which means that you're only going to have one x-intercept. Not 0. It's not going to be 0. It's going to be this right here. That's going to be the x-intercept. Now, you don't have to remember that. What I really want you to realize, though, is if you end up with a 0, you only have one x-intercept for your parabola. And the way for that to work is for the parabola to come down and just touch right there on the x-axis and then turn right around. And that's what that would look like. All of these are possible scenarios for our parabola. All right, so then my last scenario here is where instead of me giving you the equation, I'm asking you to tell me the equation. I'm going to give you a little bit of information and then see if you can figure out what the equation would be from there. Now, we are going to use our standard form to do this. And I'm going to always give you well, I say always, but for now, I'm going to give you this vertex. ultimately, when I give you the vertex, I have told you what the h and the k are in your equation, because that's the shifting. And then I tell you some other point that the parabola goes through. That point is really just an x and y that is supposed to work in my equation. So if you look at it, I'm handing you 4 variables in this equation. The only thing we're missing is this a. So I'm going to plug all of that in to the equation and then go solve for the a that's missing. All right, so the y value here would be a 1. I don't know a. The x is a 2 minus -2. Don't forget this squared. So many people forget that squared. It is a quadratic, so don't forget that. And then your k is a -3. All right, so do some order of operations here. I'm going to start inside the parentheses. That's going to turn into a 4 squared, which is a 16. Don't try to subtract here because you got this multiplication going on. You're immediately going to add that 3 to the other side. So it looks like our a value in this case is a 1/4. Now, you have everything else you need to write the equation. You've got the a, you've got the vertex. We don't need the point anymore. To write the equation, I'd have y equals 1/4 x, and then it's going to be a plus 2, because it's a minus minus. Don't forget your squared. And then at the end, it's a -3. And that's the equation that would have the appropriate vertex, but also would go through that point right there. All right, I have one more of these that I'd like you to give us a try on your own. See if you can go through that process. You can peek back at the example, but try it without peeking. Go ahead and pause the video right now and do this problem. Come back when you're done. All right, here's my answer here. Hopefully you got the same thing. If not, take a minute to look through it and see where you might have gone wrong. All right, that's all I've got for us today. Have a great day.